Hi, I'm Ryan Giefer, Wastewater Superintendent for the City of Wisconsin Rapids Wastewater Department. And today we're going to take you through a virtual tour of our facility, some of the different unique processes we have here, go through our laboratory, and get a shot of some of our equipment and different things. This is kind of an informational video for the public and different people interested in our facility. So I guess what I'll start with is a little knowledge about how the wastewater gets to this facility. Throughout the city, each home discharges its sewage into a collection of underground pipes that flow mostly under the road and end up at this facility via different lift stations. So a lift station takes the sewage after it flows by gravity, pumps it up, and allows it to flow by gravity again. So that building right over there is our headworks building, where it's the top point of this treatment facility. So all of our lift stations are pumping to that point. The wastewater is flowing through different processes. One of them is a bar screen where it's removing rags and inorganic material. Then it goes through a grit chamber where it's removing anything that settles that's heavy, like sand or rocks or things like that. After it goes through those headworks treatment processes, it ends up at this primary clarifier. And really all we're doing in the primary clarifier here is allowing the water some residence time or a chance to kind of slow its velocity and settle. So any water that gets to this tank is going to spend 2 to 5 hours in this tank. Anything heavy enough to settle to the bottom by gravity will be pumped out to our digestion process. And then the clear water up at the top, which is what you see flowing over the weirs there, is your primary clarified effluent water, which goes on to the next portion of the treatment process. So really you're letting the water get in the tank. You can see out in the middle there how the water's flowing into the tank in that stilling well. And you're just allowing a chance for gravity to pull out the heavy solids, and you're removing about 30% of your TSS, which is total suspended solids, and your BOD, which is that strength of wastewater carbon that Derek talked about in the laboratory. So pretty rudimentary type treatment system in the primary clarifier, but an important step to reduce those volatile organic solids and reduce a portion of your soluble BOD, just to lighten the load on the rest of your treatment works downstream. We have 2 primary clarifiers here in Wisconsin Rapids. We only require to run one at a time, so we're able to take turns. Usually once a year we'll switch them just to keep the equipment fresh. We can do repairs, we can do different maintenance on them. So we always have that redundancy in the event of a failure. So that's the primary clarifier. If you look here, this skimmer arm continues to go around. It makes about 2 revolutions per hour every day of the year. And all it's doing is just skimming that floating solids off. And then over there, there's what's called a Scum Beach, and that's collecting the solids that's floating, pumping them off to the digestion process. So this is the next stage of the treatment process here in Wisconsin Rapids. And this is what's called an Mbbr, or a moving bed biofilm reactor. And what's happening in here is we're taking that primary effluent that we just sent through the primary clarifier, which has got a lot of soluble BOD, so a lot of soluble carbon, some nutrients like nitrogen and phosphorus. We're putting that into these reactors, these Mbbr reactors. We're adding dissolved oxygen to them, and now the bacteria, the microorganisms, are consuming that BOD, that nitrogen, that phosphorus into their cell bodies as food by use of air for respiration, and they're treating the wastewater essentially. So if you look kind of in this tank, you can see that there's a brown color to it, and part of what that is the actual wastewater in there, and the other part of it is what we call mixed liquor, or those microorganisms. So they're microscopic organisms living in there, consuming air, consuming nitrogen, phosphorus, BOD, and really all we're doing is monitoring the amount of dissolved oxygen they have, because they require a minimum amount of DO to continue to function properly. So we have aeration basin probes that are measuring online real-time DO. There's blowers in the building over here, so they're ramping the blowers up and down based on the amount of dissolved oxygen needed to complete our treatment process. So when things in town, we have some industrial customers like Ocean Spray and Mariani, we have a landfill in town. When they're sending us a higher strength wastewater, our what we call bugs or our microbes are going to require more oxygen to treat that. So our DO is going to drop, our blower is going to go up, so it's going to put more air in the tank. At night when everyone's sleeping and there's less wastewater, less strong wastewater, the DO is going to go up, the blower is going to go down. So we're always trying to achieve the optimum amount of DO in this tank, so we're not wasting energy, we're not wasting air, not wasting electricity. So we're just trying to be very efficient, because this is the heart of our treatment process right here. This is where 99% of the BOD is removed from the facility. And as you look, you can kind of see, it's kind of hard to tell, but there's little discs in there, little wafers. And what those are that moving bed biofilm process. In most facilities that are activated sludge, so activated sludge is that free swimming suspended growth, that bacteria I'm talking about, they're in there. But there's also this media in there which allows bacteria that grab onto it, called fixed film, and now they live on all those discs. So we have two things happening here. We have suspended growth activated sludge doing the treatment. We also have attached growth fixed film bacteria doing the treatment. And the reason we have that fixed film integrated with the activated sludge is it's just a higher rate reactor. It has the ability to remove more BOD in a smaller footprint. So a typical tank this size with just activated sludge, you're going to be able to remove probably 5,000 pounds of BOD per day. This can do about 10. So you're doubling your treatment capacity by adding that moving bed biofilm aspect to it. There's different things that you learn to look for as an operator of a facility like this. Obviously you're measuring that online DO to know how much oxygen you have in there, but you're also looking at things like the foam that's on the basin. Is the foam real white in color? That signifies something. Is it real dark in color? Is it black in color? How much foam is there? There's a lot of, what's the smell like? There's a lot of things that you learn by operating these facilities that are just kind of second nature, that if you looked at the tank, you could tell, okay, we have underloaded conditions, we have white foam, so there's a lot of feel. It's almost kind of an art learning how to run one of these reactors. All right, so this is the next step in our secondary treatment process. And what's happening here is similar to what we just saw in the Mbbr, but this doesn't have that fixed film moving bed attached growth process. This is just suspended growth activated sludge in these basins. And all they're doing is, I told you we did probably 99% of our BOD removal in the Mbbr. If the load is really heavy, or for some reason BOD starts slipping through that initial treatment process of the Mbbr, we have these tanks down here to finish up any more treatment that needs to happen. So you're getting more stabilization of the wastewater with this extended aeration stage. This facility, we do have an ammonia permit, a nitrogen permit. So you need longer cell retention times to fully nitrify, to use up nitrogen as ammonia. So this stage really allows us to make sure we're removing 99% of the ammonia, 99% of the BOD, and 90+% of the phosphorus. So it's just another way, and we have the ability here, there's 4 chambers, 4 aeration basins. We have 3 on it this time. We could go down to 2 if we didn't need all the treatment capacity. We could go down to 1. A lot of flexibility down here, just to make sure we're achieving all of the treatment needs that we have. So the water comes in at the front of the basins down there. It works its way just by hydraulic pressure from the influent flow through this basin. It exits here over the weirs, and depending on flow, it's probably spending 3, 4, 5 hours in these reactor basins just to finish up that treatment process, remove the nitrogen, remove the phosphorus, remove the BOD. And from this point, it's going to flow over the weirs, and it's going to go to the splitter boxes, and it's going to go to one of our 2 final clarifiers where we remove the microbes that we just used to do the treatment. After the water leaves the aeration basins, we're able to split it between 2 final clarifiers by use of these gates. So right now we have half of the half of the flow going to our larger final clarifier, the one to the north, and then the other half is over here, which is going to the southern final clarifier. And you can see that if we were to have a hydraulic incident where the flow went too high, we could start opening these gates to allow more water to move through the facility. This is the next stage in the treatment process. This is really the last stage before disinfection, which then goes on to the Wisconsin River. But this is our final clarifier. We have 2 of them, this being the larger of one, 125-foot diameter, 1.3 million gallons. What we're achieving here is we're taking that activated sludge treatment process, which was the microbes using air to treat the wastewater. Now we're just allowing gravity to settle them out to the bottom, and the clear water that stays up near the top flows over the weirs and onto the next treatment process. So again, this is kind of like the primary clarifier, but instead of settling out raw influent wastewater, we're now taking what we feel is the treated wastewater, settling the microbes out of them, sending them on to the digestion process, and taking the clear water, sending it out to the disinfection process and onto the Wisconsin River. So nothing real magical happening, just water entering the middle. You can see there's a brown color to it. That's the microbes. They're settling to the bottom, just like the primary clarifier. Anything that floats in the top is being collected by that arm right there, which is about to go over the beach. And you know, we're removing 99% of the microbes in our water. So what this is it's a sludge judge, which is just kind of a rough way that we measure how much blanket is on the bottom. And when I say blanket, I mean we're trying to settle out microorganisms to the bottom, so there's going to be a blanket of them laying on the bottom, and we're going to suck that out with our pumps. And if you kind of want to have an idea, a quick snapshot of how much is in the tank, we have these clear tubes, and this tank is about 12 feet deep, so you got to have a pretty long tube. And you're literally just kind of sticking it in there, and it's going to give you a profile of what it looks like if you could see the side depths. You can see it's nice clear water up top, and it stays pretty clear until you're getting near that bottom where you see probably 2 feet of that darker, what we call flock. So that's the microorganisms that you're trying to settle out. Send some of them back to the treatment process to do it again, and waste some of them into the digesters to be treated with the solids. So that gives you kind of a profile of what the tank looks like underneath. And we have these for secondary clarifiers, so we kind of know what's happening to the secondary clarifiers. We have them for primary clarifiers, so that you can tell what sort of a primary blanket you have, because you don't want to let your blanket get too thick, otherwise you run into pumpability problems, you can run into septicity problems, odor problems. It's just another control mechanism for us around the facility. The last stage of treatment we do before we send it onto the Wisconsin River is housed in that building there. And it's not disinfection season right now, so there's not going to be anything to see. But between the months of May 1st and October 31st, we have an ultraviolet disinfection system, which is a bunch of UV bulbs in big racks that we set down into the channel, so the water is routed through a channel. And in that channel is about 190 different ultraviolet disinfection bulbs that are disinfecting anything remaining in the water. So if some of the bacteria get through the final clarifier, or there's some contaminants, they're going to use ultraviolet light to kill and disinfect the water, and then it's going to go on to the Wisconsin River, where it'll be safe for boaters, fishermen, swimmers, you know, any recreation that happens in the river during those months between May and October. We have the disinfection running so that we're protecting them from the small amount of bacteria that we might be pushing through the facility in the event of an upset. So basically, those 4 stainless steel cabinets that you see, and then the control panels over there, are the UV disinfection system. And underneath the grates in those channels would be where the bulbs are sitting in the water. So we're controlling them from all those different points where they're connected to the actual control modules, and they're ramping the light up or down based on the transmittance in the water. So if it's nice, good, clean, clear water, the UV system's going to ramp way down. If we're having a little bit of issue or we're having some turbidity in our effluent, it's going to ramp the UV system up, and we're going to get a better kill on the bacteria that might be moving through the system. So yeah, the water is moving through these channels, and if you look right here, you can see that we have weighted gates that are modulating to keep the level in the channel where they're supposed to be, to make sure all the bulbs are staying submerged, and that's all based on hydraulic pressure. We just got done talking about the whole liquid treatment process, which was that influent wastewater, its primary steps, its secondary steps, the disinfection steps, and then it going to the river. And the whole time we were talking about solids that settle after we pump to the digesters, and that's what we're talking about here. Is we have 3 different digesters, all anaerobic. 2 of them are thermophilic digesters, which means they're heated to 131 degrees Fahrenheit. This larger last step is like a secondary digester, and that's a mesophilic, so that's only heated to about 98 degrees Fahrenheit. And what you're doing in these digesters is you're pumping in those solids we talked about, those volatile organic solids. You're creating an anaerobic condition, you're heating it, and you're mixing it, and it's no more complicated than that. And in that anaerobic heated condition, you have anaerobic bacteria that starts to grow, and they're consuming the volatile organics. They're reducing the volatile solids in these tanks by 40, 50, 60%. So you're actually getting up to 60%, 70% just reduction in overall material from going anaerobic and heating. So that's pretty amazing that you can put things in a tank, take away oxygen and heat them, and you can lose 70% of your volatile organic content. So that's neat. And what happens is that as a byproduct of the anaerobic digestion process, they make hydrogen sulfide, they make water, or they release water, and they make methane. And that methane is stored in these covers, so you can see how they're kind of up off of the tanks. That's because they're literally floating on methane gas, and that methane gas is then collected, and we burn it in a biogas generator to make our own power throughout the facility, to help supplement heating of the digesters. We also have some boilers that are fired by the methane to heat the digesters. So it is a fairly self-sufficient process. We still do buy some natural gas to heat them. We still do buy some power from the utility, but we're able to really supplement our own resource costs by way of using that methane. So it's kind of a neat process. We go through, after we digest in our thermophilic digesters, we go to the meso, and then we dewater it into a cake solid, and that cake is then land applied as a fertilizer. And we're actually a Class A facility here, one of the few in Wisconsin that I know about right now. And we achieve that by way of the TPAT process. So that thermophilic process that heats to 131, the DNR says that's sufficient in making a Class A product. Now that product, being Class A, can go anywhere you want it. There's not a lot of restrictions. You can use it in your yards, your gardens, farm fields. You could dry it and bag it potentially. We typically are trying to give it away or sell it to farmers for agricultural uses. But really kind of a neat process that we'll get into a little bit here. So these are the ultraviolet disinfection banks and bulbs I was talking about just before for disinfection. Disinfection season runs between May 1 and October 31. So right now it's not disinfection season, so we have them in their racks and we're doing maintenance on them. We're replacing burnt out bulbs, replacing seals, fixing sleeves. You know, there's a lot of maintenance that goes into this system, but it does a really good job. Very robust system. There's 26 banks we have here, 196 different individual bulbs. Each bulb is about $300. Plus you have electrical components, quartz, sleeves, seals. It's a costly system, but it's a robust system that does a phenomenal job of disinfecting, you know, upwards of 5-6 million gallons of wastewater per day. That TPAT digestion process I was talking to you about, where you're anaerobically digesting the solids in your facility, after the digestion process is complete, we have this fan press, several different fan presses, and what you're doing here is you're pumping the digested solids through the press. You're adding a flocculant to it to help it flock together and thicken up, and then you're squeezing water out of it. And the byproduct, I guess he doesn't have it running right now, shoot. But you can see the water that's coming out down there is clearer, thin water that you're squeezing out, and you're ending up with a thicker cake after this process is done. You can put about 150 gallons a minute through this machine, and we basically use it to keep the digestion process, to keep the level down so that this is the control mechanism for where we're running the anaerobic digestion process. If we need to make room to put more throughput through the facility, we run this press harder, we fill the truck, take it to a drying pad. So you're squeezing out the water, you're thickening it, you're making it into a cake. We're putting it in a blacktop pad, turning it with a compost turner, and now you have a much thicker, almost soil-like biosolid that we're giving away or trying to sell to farmers and local residents of Wisconsin Rapids. So these are our two rotating drum thickeners. They're both 400 gallon per minute units, so we can do a total of 800 GPM through this process. Really all you're trying to achieve here is you're taking that waste activated sludge I told you about, adding a flocculant to it so it thickens up, wants to release, shed that clear water, and it's moving through this big rotating screen drum, and the water is falling out of it as it goes. So you're putting in a thin product here with a flocculant, it moves its way across the rotating drum, and on the back end you have a thick 5-6% solid waste activated sludge. So you're removing clear water so that your digestion process doesn't have to deal with as much cold clear water. All right, so this is our CHP, combined heat and power biogas driven generator. It's a 330 kW unit, so we can produce 330 kW kilowatt hours per hour with this unit. And like I was talking about with the anaerobic digestion process that has a byproduct of methane and H2S, we're capturing that methane in those covers where it's stored, creating pressure. Now, as we ramp this generator up and down, that's going to determine how much gas we're pulling out of those covers on the anaerobic digesters. And we're constantly trying to match the gas production to the kilowatt hour production with this unit. And when we're running well, we have a lot of methane. We have plenty of high strength waste coming through. If we can run this wide open, we can be 70, 80, sometimes 90%. We've had a few times of 100% self-sufficiency from the electric utility. The problem is that, you know, as your digestion feedstock changes, your methane production changes, so there's going to be times you're going to run it lower, you're going to have to buy more electricity, but we do have the ability to make all the power we need. It's just not an everyday occurrence here. But, you know, we are, I think in 2020 so far, we're averaging about a 62% coverage of our own electrical bills. So that's a huge chunk. For a facility this size, our electrical bills are between $10,000 and $15,000 a month, and now you're taking away half to 60% of that cost. So it's a big deal for the utility. And we have a control panel here that lets us do all of our self-diagnostics, lets us know what's happening, engine temperature, oil temperatures, cylinder head temperatures. I mean, it has more information than we can even really use. But it's a great tool for us to understand what's happening. One of the issues with burning biogas or methane is that it can be dirty, or it's dirtier than natural gas or diesel fuel. So we're dealing with cylinder buildup. You get what's called siloxane buildups on your cylinders and your cylinder heads. So we're always watching those temperatures to know when we need to pull those apart, clean them, change the spark plugs. There is a lot of maintenance that goes into this CHP type process. But you can see right now we're running at 300 kW, so we're almost at full speed. And when we get back into the control room, I can show you. It'll actually give you a kilowatt being purchased from the utility and kilowatt being produced. And right now we're probably producing the majority of our own right now. So pretty cool. This one here is a gas-fired, natural or methane-fired boiler. And this one here is just a heat exchanger. They can be used interchangeably. The reason we prefer to use the heat exchanger is because that CHP we just looked at, the loop that goes through the block of that engine and through the exhaust of that engine is piped over to here and actually keeps this at 180 degrees all the time. So instead of having to burn a bunch of natural gas or use our methane in this boiler, we can use that CHP, which is making heat, already making power, also to heat up our digesters. So the sludge, the digesters are on either side of us right now. The sludge is pumped through these tubes, and there's that hot water jacket inside of here. It's heating that sludge up to that 131, 132 degrees, and just trying to maintain that temp at all times. The feed sludge we have, so that primary settled solid I talked about, that waste activated solid, the high strength waste we take, which like the grease traps from town, food grade waste, that's also pumped through this heat exchanger to pre-warm it. We have the ability to do that or not do that, but if we can pre-warm some of that cold feed, that also helps not have such an energy demand on that drop in temperature. But you can see there's quite a bit of components here. I don't know if you want to get a shot of these three-way actuators. Because this is that Class A T-pad batch process I talked about a little bit, you have to isolate each digester every single day. So you have to feed one and hold it, feed one and hold it, back and forth. So you have these large actuators that are turning every single day to switch which digester is being held, switch which digester is being fed. So there is quite a few components, a lot of equipment that we're maintaining here to make this Class A T-pad work. This down here is what we call like the pipe gallery, I guess you might say. So all of the processes on the solids end of things I was just talking about have at least 2 or 3 mixing pumps, 2 or 3 feed pumps. The RDTs have 3 feed pumps as well. You know, there's just for every single component and process we talked about, you've got piping, you've got check valves, you've got plug valves, you got motors, pumps, seals, solenoids. So there's just a ton of components and equipment and maintenance that has to go into every single thing that we're doing. And you kind of get a little idea of how much. So the only thing we're looking at here is RDT feed pumps, and Fournier fan press, mixing, and feed pumps. So just those two processes alone, you're talking about all this equipment that we have to maintain. So there is a lot that goes into it, and it's part of the reason that we have 2 full-time mechanics, 3 full-time operators, a chief operator, seasonal help. Treating 3.5 to 5.5 million gallons of wastewater a day requires a lot of energy and a lot of equipment. All of the stainless piping you see down here is all the biogas being collected, whether it's being produced, stored, or sent to its ultimate use, being the CHP or the boiler. It's going through different drip traps because, like I said, when these anaerobic bacteria make hydrogen sulfide, methane, and they also release water, you have to get that water out of your gas before you can use it. So these drip traps are allowing the gas to come to a point where it spends a little more time. The water wants to settle out to the bottom. You can see that it's releasing water all the time. So there is a fairly significant amount of water that has to be removed. Some facilities are going to also send that biogas through a treatment process before they burn it in their CHP, whether it be H2S removal media or siloxane removal media. We don't have to really do that. We remove moisture and we burn it in the engine. Another thing we did here recently, and we did this all in-house, was we were having a significant issue with our heat exchanger that heats our digesters fouling with what's called Vivianite, which is a hard precipitant that comes out of the sludge when the temperature swings. And it's a combination of several nutrients. I think it's magnesium, iron. There's like 4 or 5 different nutrients that combine to create this precipitant. And it was severely diminishing our heat transfer across our heat exchanger. So what we thought about doing was we took some of this piping, all the painted piping is what was original with the upgrade, and we built some of this new stainless piping to bypass the heat exchanger with the feed. So you're taking that real cold temperature feed, which was causing a big swing in temperature, and removing it from the heat exchanger. And it's been pretty successful, but we had to install, we had to core through the wall, install all new stainless piping, install a new 3-way actuator, and then all the stainless piping you see in here we kind of designed and did in-house with the help of a mechanical contractor to sort of manipulate the TPAD process in a way it wasn't really designed to be, but it has proven to be pretty successful with minimizing that Vivianite fouling on our tubes. So kind of a neat in-house initiative that we came up with that's been pretty successful. Okay, so what's happening in here is when I was talking about the anaerobic digestion process where you're taking the volatile solids, putting them in an anaerobic tank, heating it and mixing it, that's all that's happening. This is how we mix it in Rapids. So we're taking that methane gas that's being produced, sucking it out of the top, bringing it into these gas compressors, sending it back into the tank in what's called a cannon. It's a huge barrel in the middle with all these different holes in it, and you're just letting that compressed methane make big long bubbles and tumble, and it just mixes the tank. So we're using the gas that's being produced, we're using it to burn, we're using it to fuel our boilers, and we're also using it to mix the tank. So it's a pretty sustainable way of doing it. Some tanks have mechanical mixers where there's things moving, some have extra pumps with nozzles where they're pumping. We're using gas to try to turn over our digesters. And you can see there's quite a bit going on here. You have to remove the moisture again, so you have these moisture removal vessels. You got to measure all your pressures on your discharge side for the cannon. So there's another fair amount of things to be monitoring, maintaining, and working on. So it's a good technology. It works well. Just quite a bit of components to it again. 5 MCCs we have in the facility. And what's happening in here is you're basically just getting an electrical point where you have access to all of your equipment, its fuses, its control mechanisms, some indicators of whether it's running, whether it has faults. You can lock it out if you have to work on it. Any of the control type electrical things are routed through these MCCs so that we have the ability to isolate the equipment, work on the electrical components all in a central location. And we also have control panels here with touchscreens that allow you to look at the whole facility from one point and make adjustments on the fly. So what this tank is here is, when we were talking about the microorganisms that we're trying to settle out of the process in the final clarifiers, I had said that the majority is returned back to the process to continue to treat. Some is what we call wasted out. It turns into waste activated sludge to be thickened in that drum thickener we talked about and then sent to the digester. So it's just our way of controlling how many microorganisms we have in the facility to do the treatment, putting them through the digestion process, and now they become part of our biosolids. So here's where we're holding them. It's aerated to keep the odors down, to keep it suspended, keep it fresh so that it can be thickened properly in the RDT. So the last thing that we haven't really talked about yet, we talked about the laboratory, we talked about the process, liquid and solid, talked about some outside the fence things. The last thing I wanted to touch on was our what's called Supervisory Control and Data Acquisition System, or Scada system. And that's basically this group of computers here that gives us the ability to control basically the entire facility, and we do have the ability to do it from home as well. So we can log into the system from home, check what's going on, make adjustments. It lets us staff this facility with considerably less manpower than would otherwise be necessary. So we have process logic controllers on virtually every piece of process equipment. So the primary clarifiers we talked about, you can go to that piece of equipment, click on it, shows you all the equipment that's necessary for it. That spinning arm we talked about, that's this drive right here. So you can see it's lit up green, so we know it's running. The scum pumps that pump off the floating solids, the pumps off the bottom that we talked about, which is your primary sludge pumps, which are here. So as you click on every component, it's going to take you to the page and lets you monitor what's happening, how often it's pumping, when it's pumping, is there an issue with it, are there alarms? So it really just gives us the ability to operate the plant, with minimal staffing. Let's see here, if we go to the overview, you can see here's our 3 thermophilic digesters that we talked about. This is actually the volume of gas in them right now. So if you look at the sequencing page, we've got 40,000 cubic feet of gas right now being stored in those 3 covers, and that's the maximum is 50,000. So we're approaching the maximum amount stored. So we're probably going to bump the speed of that generator up a little bit more, make a little more power and a little bit more heat. If you go to the overview for the collection system, we get an idea of what every single lift station is doing in the city just from these 2 pages. Shows you the wet well level, where the pumps are going to start and stop. Shows you individual lift stations. So you can see here, Dewey Street Lift Station, number 1, is currently running at 56%. So even the 17 lift stations that are throughout the city, we can sit right here and tell exactly what's going on. Buren is a municipal customer of ours. We can monitor what they're doing. Right now, Buren's sending us 161 gallons per minute via one of their monitoring stations, the other they're not using currently. So it's really kind of neat. Just a lot of information here. And this kind of shows just a quick snapshot of all lift stations throughout the facility. You can see we're here at the master, and we're talking to each one of these remote stations. We can even tell trends. This is showing the lift station wet well levels. You can see as the pumps fire, pumps it down, slowly builds up, pumps fire, pumps it down. So come in here in the morning and have a pretty good idea of what's happening throughout the facility in about 10 minutes. As the water is leaving the house, it's going to flow through that network of underground pipes by gravity, and then the lift stations. So say you live on the west side of town over near Gaynor. It's going to leave your house, it's going to run down Gaynor, and it's going to hit West Side Pumping Station. West Side Pumping Station now, as the level goes up or down, you're going to have pumps that run faster or slower. You could have up to 4 pumps running at once. They're going to pump it right here to the wastewater treatment plant. Other smaller plants like, getting caught here, are going to pump, like say Washington. That's going to pump all the way over to Dewey. There's little lift stations that are going to contribute to the larger lift stations. The 4 stations that actually come right here to the plant are West Side, Dewey, Pepper, and 2 Mile. So those are our 4 largest stations, and they're all lifting water to the wastewater treatment plant. So I think that's probably about it for what I will need to go through from the Scada, but just kind of another efficiency that we're trying to take advantage of to do the best job that we can.
My name is Derek, and I'm the Chief Operator at the wastewater treatment plant. This is the laboratory. We're going to go through some of the tests we do here at the facility daily. The first thing we have here is some samples of the influent water coming in. You can see there's a lot of solids in it. This is in between our processes after it settles out. So this is the primary effluent. And this is actually our final product that goes out to the Wisconsin River. You can see that it is a lot more clear. There's a lot less TSS in it. And overall, it has less carbon, less nutrients, and a lot less pathogens in it. Here is kind of mocking our final clarifier. Before the final clarifiers, this would be an aeration basin where it'd be all mixed up. Right here is a level of mixed liquor, suspended solids. That's basically what's doing most of the work at the facility. It's the secondary process. When we have to get rid of our solids, we waste them out, and eventually they end up in our digesters, which is this right here. So this is digested sludge. That's what that looks like. It's very warm. So we're gonna go into some of the testing. Our main test that we do 7 days a week is our biochemical oxygen demand test. We monitor that right here. Basically, we are taking a DO probe, measuring dissolved oxygen in versus 5 days later, dissolved oxygen out. We do some calculations, and we can basically compare the demand of dissolved oxygen is comparable to the amount of carbon in your water. Another test we do 7 days a week is pH testing. We do that on our final effluent every single day. We got to make sure that our pH is neutral. So our fecal permit runs from May to October, end of October. This is a fecal bath. So what we do is we run membrane filters on an auger. All that stuff is kind of in the refrigerator, so you can't see it, but it sits in an incubator for 24 hours, and then we read out the auger plates and the colonies. A test that we do 5 days a week is total suspended solids. That's basically everything that's organic and inorganic is suspended in the water, and we need to make sure that that is getting out of the facility. It basically it has a lot of nutrients in it, it has a lot of phosphorus, it has a lot of carbon, and there's things that we don't want to go to the river, and our permit doesn't allow a certain amount of nutrients and biochemical oxygen demand to exit the facility and go into the river. One of the main tests we do is a total phosphorus test. We have to run phosphorus 5 days a week. We do it all in one batch because we're able to save samples. It's a more extensive test. Our permit on that is 1 milligram per liter. We usually try to keep it around 0.5 though. That's a test that involves digestion, an acid digestion, and we read them out on a spectrophotometer. So not only do we do permit testing here, but we do a lot of process control testing. This lab is where we find out like how well the plant is running. This is where we make our changes based off of our numbers in here. It's basically kind of the heart of the facility. Over here, we have different graphs that show basically our quality control. There's many things that we have to do in here to make sure that this lab is running properly per the DNR. We have to do calibration checks, we have to do LOD checks every quarter, and this is kind of where we just keep track of all that. We have graphs of where we should be, and you can see that we're hitting our marks very well. Just verification charts, everything that the DNR requires us to keep our permit and maintain it. And when they do a lab audit, they would go through all of these things.
So What we just kind of went through was the whole in-the-fence treatment process at this facility. We went through liquid train treatment, we went through solids treatment with our anaerobic digestion process. We covered a lot of topics. What we didn't really talk much about was the outside the fence things. So all the homes throughout the city of Wisconsin Rapids have their lateral connection pipe connected to our sewer main under the road typically, and that water flows to the facility like we talked about, to lift stations. What we didn't talk about though was all the maintenance that goes into that. You know, we have these 2 vac trucks here that are constantly cleaning those pipes, jetting them out, cutting roots out of them if they're getting old, cleaning the catch basins for the stormwater utility, televising all the sanitary and storm to make sure we know what condition our pipes are in, where we need to be focusing our design and replacement efforts. So there's a whole nother department within the wastewater department called the collection system department, where we have 2 employees that are doing what I said, televising, root cutting, operating these trucks, assisting the street department. So it's a whole nother ball game when you get outside of the fence. And there's such important maintenance that happens there, because if our sewer mains don't flow properly, you start backing things up, which backs up homes, you get a lot of mad residents. So the job that these guys do here is just as important as what we do in the treatment facility. And with that, you know, sometimes we get into challenges with things that get flushed down the toilet or put down a drain that shouldn't be there. Things like, you know, those Clorox wipes. A lot of them say flushable on them. In our eyes, they're not flushable. They do not belong in our system. You know, the only thing we want to see is that organic human waste and toilet paper. Anything else is going to cause us issues. And as a resident of the city, you'd want to be worried about things that cause us extra work because they're going to cost more money, which is going to potentially affect rates. So it's important for homeowners to understand that the better they treat their plumbing, the better it treats our system, the easier it is for us, the cheaper it is for us. Those extra things like pulling pumps that are plugged with rags or unclogging sewer mains under the street that are plugged up, you know, it just costs more money, more time. It's not good for the environment. So it's important for everyone to just recognize how important it is to be responsible with how you use your sewer lateral and your sewer system in front of your house and your internal plumbing of your house as well. You know, it's just as important for that. So just another thing we do here at the wastewater department that we find to be very important, and we try to do the best job we can. We have these 2 vac trucks. We should probably get a shot of the lift station or the televising unit as well. Okay, so this is our actual televising rig, which was recently replaced in the last 3 years, and it's really a pretty neat setup. So like we were talking about with all those sanitary main lines and things like that, we have this little camera that we can drop down into the actual sewer, and then by way of remote control from the laptop, or he actually has a little handheld controller, he can drive it throughout the network of pipes, checking condition, looking for issues, cracks, roots, offset joints, just simply checking what's the composition of the material. If we don't know, if we haven't been in this part of town and it's older, what do we have under the ground? Is it clay pipe? Is it old galvanized? You know, just assessing the condition of our system is extremely important as well. Or if we have issues and we're not sure what the issue is, you can drop this guy down there and visually see what's happening. Another thing it's useful for is where all these lateral lines are connecting to the main line of the road. You can drive up with the camera and you can turn and look into it, see, is the connection point to the main, is there issues there, is it broken, is there roots? So just another crucial piece of equipment that we take advantage of really on a daily basis here at the wastewater utility. Yeah, another one of the issues, so we talked a little bit about the flushing of inappropriate things, the Clorox wipes and the issues it creates for us. Another big issue that I think a lot of people don't know about is what's called inflow and infiltration. So that's clear water entering the sanitary sewer system. You know, in the sanitary sewer system, you don't want rainwater, you don't want clear tap water if you can avoid it entering the system. It just causes us to have to treat more gallons, pump more gallons. The costs go up for us when things like that happen. And a lot of times when we start seeing flows at the facility going up, we can take our camera, drive through different areas of town and try to figure out what's happening. Is there a crack in the main line so there's groundwater coming in? Is someone having an illegal sump pump hookup where they're pumping water out of their basement into the sanitary connection? Our camera can see that. So that's another thing that a lot of people I think in the city maybe don't realize is that when you have a sump pump in your basement, that shouldn't be connected to the sanitary system. That should be connected to either the stormwater system in front of your house or out into your backyard or down the curb into the stormwater. That's stormwater, that is not sanitary water. So that's another issue we have when it rains an inch or two in the middle of the night or whenever we see our flows go up. Sometimes we have to take our camera and try to identify where is all this extra clear water coming from. So it's another initiative we're trying to kind of bring to the forefront here in the utility is getting a handle on illegal sump pump hookups, a handle on where I&I may be coming from, replacing areas that are cracked, having I&I, just really trying to get a better understanding of it, and it'll be much easier for us to do that with the support of the residents in Rapids, fixing those illegal sump pump hookups if they have them. So a couple things you're looking at in here. Ben and Jesse, our two collections guys, they have computers. So we work real closely with the engineering department in the city and the GIS specialist. So all the things that we televise can be uploaded to their software, and that way the GIS specialist can create maps that show, okay, if we want to know in the city where's our worst root areas to be focusing on, he can take all that footage, create a map, boom, now we know the main areas we should be cutting for roots. He can do that with catch basins. I mean, uploading our data and giving it to engineering and GIS just makes it more valuable information for people to have for design purposes, replacement purposes. It's just another efficiency that we're trying to take advantage of. This other thing here is an actual push camera, and what that's able to do is if you're going to go into a home or a smaller line where you're not going to be able to put the motorized camera, is you can put that in there and you just push it and it'll pan itself out and you can record it on there as well. So we have smaller components for residential lines, just another flexibility that we have. So along with all the maintenance we were talking about around the facility, I told you we have two full-time mechanics on staff. The other thing that our mechanic takes care of is maintenance at the lift stations. So you have the collections guys taking care of the underground pipe networks, helping clean the lift stations, but now this is our maintenance truck, and he actually has this motorized crane so he can pull submersible pumps throughout the city. Most of our lift stations and the way we're designing them moving forward are large cement structure wet wells with submersible pumps. We feel it's probably the most efficient and the safest way to do it. Instead of doing confined space entries, working underground, we just send the pump down submersibly, it pumps, we don't worry about it. When it has a problem, we have our crane, we can pull it out, bring it back to the shop, work on it, replace seals, replace impellers, do different type of maintenance activities. But another task of our maintenance mechanic is also outside the fence lift station maintenance, and we have 17 lift stations throughout the city, so it's not a small task to be monitoring and maintaining them. We're tracking things like daily electrical usage, daily water usage, daily natural gas usage, so that we know when things are changing. We know we can even usually tell if someone in a part of town on a smaller lift station has a leaking toilet because we see our flows going up. We say, okay, somebody's using more water than they should. We should probably call the water department, or we should just try to figure out where we're getting the extra water from. So we have it dialed in pretty closely. We were fortunate in 2019 to be awarded the Central States Water Environment Association Operations Award. It's a fairly prestigious award. It's one winner in the Midwest each year gets this award, and it's basically it's weighted by how your operations are. Have you been making operational improvements? They look at several different components. And since 2017, when I started here, we've experienced some issues with settleability. We've experienced some issues with slug loading from our industrial customers. So we had some things that needed to be addressed. And within the first couple of years, the staff here has done a phenomenal job. We've been able to identify some of our issues with phosphorus deficiencies and slime bulking. And all those things we're able to identify and then solve has led to greatly improved overall treatment process here. Single digit parameters in our effluent for TSS, BOD, nutrients. So the facility is running extremely well, and I'm extremely proud of the staff for what they've been able to accomplish here. And it speaks volumes to receiving this award because of what we've been able to do. And I just couldn't be more grateful to receive it. And just the staff deserves a ton of the credit for this, and couldn't be happier about it. So some other recognition that we received recently was the 2020 Laboratory Excellence Award that was awarded to Derek Budsberg, who's our chief operator and laboratory manager. And myself and Joe Terry nominated him for that award based on his outstanding performance mostly. Since taking over the facility in 2017, there were a lot of things that Derek and I knew we needed to address, and chief among them initially was getting the laboratory in better compliance, updating some methodology, rewriting some SOPs, training lab staff, all these different things. It was a daunting task, and Derek took them on single-handedly and has done a phenomenal job. And we currently have our laboratory putting out some excellent analytical data, just extremely accurate and reliable. And Derek took on the task of rewriting our laboratory manual, which is a huge task, and he did it, right away within a few months of starting. Derek made some suggestions to us about some additional sampling we could do to help try to get a better handle on our nutrient balance throughout the facility. Just a lot of really great ideas and some excellent work in the laboratory led to Derek receiving this award, and I'll let him talk a little bit about it.
To reiterate what Ryan just said, some of the things that I had to do in the lab was update some of our SOPs. We got extra pieces of equipment, some more equipment to help us get more accurate data in the lab. One of the things about taking data is that it needs to be accurate. Without accurate data, we can't run this plant the way it's supposed to. So I implemented a lot of process control checks that we do daily to make sure that the plant is where we need it to be. Some of the other things I did was added different sampling points to make sure that we're taking the most accurate data possible.
So I'm extremely proud to announce the City of Wisconsin Rapids has received American Public Works Association Project of the Year Award in the environmental category for the force main that runs from the west side lift station to the wastewater treatment plant. This is a prestigious award. It's the only one offered in the entire nation. We're really proud of the project and the amount of work that went into making it happen. Hopefully, most of the public didn't even know we did it. And with many of our public works activities, when we're doing our job, nobody knows about it, right? You can take a lot of things for granted, but this project is not one that should be taken for granted because of the amount of work and preparations. The wastewater effluent from the west side that flows to this plant has to cross the river, and it crossed for decades under the river from the original wastewater treatment plant that was built in the 40s. When the new plant was built here, that old plant was converted into a lift station. That's our west side lift station. A new force main was laid across the river bottom and works its way over to here. Over time, that pipe material has deteriorated, and the city spent several years in the process of designing and planning a new west side lift station project and a force main project. We were going to do that in phases, but there were some telltale signs that force main was close to failing. Just some of our maintenance checks, cathodic protection that's there to prevent corrosion. We were losing continuity there, which is an indication that there's some faults in that system. And so we ended up moving the project up. Instead of laying a new main across the bottom of the river, we ended up selecting a method of horizontal directional boring. And so this main is bored through rock all the way across the river. And in doing so, really ensures an environmental friendly solution. The potential for a spill or a failure is dramatically reduced. But part of the reason the city won this award was the coordination required. The cooperation between the consulting engineer, Strand Associates, the construction company, the general contractor, A1 Construction, and the City of Wisconsin Rapids staff is what really made this project move forward extremely smoothly. There's just a lot of cooperation. Costs were kept down because of it, and the project was done on time and on budget. When the physical connection was made from the old force main to the new force main, we had to shut down that lift station. And I can't be prouder of our staff here at the city who worked with our industrial customers so that they were aware and could slow down their production as much as possible during that outage. They went and pumped down all the lift stations and timed that so that when we actually shut down and we're starting to have to fill tanker trucks and haul that material over here to be treated while that connection took place, that was minimized. And the contractor having additional trucks on standby in the event that they were needed. It was a 12-hour process, and that process took a little longer than was expected because we had a valve that we weren't aware of that was hung up, but it went flawlessly. And it happened overnight when flows were low, and staff just worked long hours to make it happen. At the end of the project, we've got a new main and reliability for the city for the next probably 100 or so years. And this is an extreme high point in a career to see our project receive a national award and to have staff here at the wastewater plant that have really done an exceptional job over the last 5-7 years. Just fantastic level of discipline to take a plant that we were struggling with, and we had experts reviewing and analyzing things, and so many things unanswered. And to have our own staff sit down and put their nose to the grindstone and figure everything out. These awards that the city have received are prestigious and well-deserved, and really goes to show how hard our staff are working to serve the community here. And I just have great pride in them and the work that they've done.
So that completes our tour for today. I want to thank everybody for watching and participating, and thank everyone who was involved in helping make this possible. Community media for Wisconsin Rapids, the staff member here at the plant. A lot goes into putting something like this together, so thank you to everyone. Also, just hope everyone that views this learned something, found it interesting. I think it's good in this field to be able to show what you do, kind of give people maybe a little more appreciation or a little bit more education related to what goes into this and what goes into treating wastewater. There's a lot to it, and we have a very large responsibility in protecting the environment and the river and our water sources in the state. So very proud of what we do here. Appreciate everyone's time, and thank you very much.